Hi everyone, so this video is a review on ideal gas law equations. Just remember, an ideal gas law is a gas that follows the kinetic molecular theory, and the formula looks like this. So PV equals nRT, where P is pressure. Pressure has to be in the units of ATM, so if in your problem it's given to you in mmHg or torr, you have to convert it to ATM. Volume has to be in liters. Same thing here. If the problem gives you milliliters, you have to convert to liters. N is moles, MOL. R is this constant right here. So this number will never change for R. So R will always be given to you, and it will always be this number with these units. Now, I like to write the units of R because this tells you what your other variable units have to be. So for example, liters, that means volume has to be liters. ATM is pressure, so that means pressure has to be ATM, and so on and so forth. And then T is temperature, which has to be in the unit of kelvins. Again, if it's not in the unit of kelvins, this formula will not work. Okay, so let's look at our first example. The question says, at what temperature will 0.654 moles of neon gas occupy 12.3 liters at 1.93 ATM? So the very first thing that you should do is write your formula. So PV equals nRT. And then we're going to list our variables, PV, nR, and T. So pressure is in the unit of ATM, and in our problem, it is right here, so 1.93 ATM. V is volume, so remember volume is liters, so 12.3 liters. N is moles, 0.654 moles. And remember, R is this number right here, so that number will not change, so 0.0821 liters ATMs over moles times Kelvin. And T is temperature. Now the question says at what temperature, so we know that we're going to solve for T. Okay, so the next thing that we have to do is get T by itself in our equation, right? So when we're trying to solve for T, we want to divide R and N to the other side. So if we divide NR, so the N's cancel out and the R's cancel out, and whatever I do to one side, I have to do the other side. Okay, so I'm just going to flip these so that T is on the left side. So now we have T is equal to PV over NR. Okay, and now we can just plug in some numbers. So P, we have 1.93 ATM times V, which is 12.3 ATM. Oh, sorry, 12.3 liters. Divide that by N, which is 0.654 moles, times R, which is 0.0821. Okay, so when I plug this into my calculator, I want to make sure that I'm using parentheses, especially when you're dividing. Okay, so we have 1.93 times 12.3 divided by, open parentheses, 0.654 times 0.0821, close parentheses, and you should get 442.12. And remember, if you're unsure of the units here, you always want to go back to your R value and take a look at those units there. So in this particular case, because we're looking at temperature, our unit is going to be in Kelvin.